Hey, it's Mr. Luneski here with Unit 1, Section 2. Today we're going to be talking about segment addition. We're going to focus a lot about line segments. Before we get started with our notes, though, I'd like you to imagine a scenario, if you will, that let's say you are sitting in class and you have your pencil, and the pencil is 7 inches long. And your neighbor next to you is like, I don't have my pencil today. Can I borrow yours? I don't know why they sound like that. But you're like, oh my goodness, all right, yeah, here, let me give you a piece of my pencil because you don't have an extra pencil. So you break off a piece of your pencil, and let's say that that piece is 3 inches long. So now the question at hand is, how much pencil do you have left? Sort of feel like Dora the Explorer right now, kind of asking you a question, and I'm not going to hear what you say. But if the original pencil is 7 inches and I break off a piece that is 3 inches, hopefully you responded that, well, you'd be left with a piece of the pencil that is 4 inches. That essentially, right there, what we just did is essentially segment addition. So, what I would like you to do right now, take a moment, pause video, copy down these definitions. Okay, welcome back. A line segment. A line segment is part of a line that is defined by two endpoints. We denote this as this. So, last video, we talked about lines. This is what's known as a line segment. A line segment has a start and a stop point. So this is a line. This is a line segment. This line goes on forever and ever and ever. This segment starts at A, stops at B. So hopefully you know the difference now between a line and a line segment, and it is important to know the difference between when I use these arrows and when I don't use those arrows. The word betweenness means that if you have 3 points that lie on a line, that you can always say that one point is between the other two. Saying that something is between something does not necessarily mean that it is in the middle. So for example, if we look at this line or this line segment down here, we have segment PQ where point M is between that. It's between P and Q. It's not necessarily directly in the middle. Does that mean that it can't be in the middle? No. Points can always be in the middle. But if I say between, it just means that it's somewhere floating between those 2 points. So, segment addition postulate basically says that if I have a line segment and there's a point in between the two endpoints, that I can say things like PM plus QM equals PQ. So one way that I'm going to describe this is to say that, well, PM is part of this segment, and MQ is also part of the segment, and PQ is the whole segment. So I can say this part plus this part equals the whole thing. Think back to the pencil. If I took the 2 pieces of the pencil and put them back together, it should equal the whole pencil again. So that's what segment addition is all about. So let's take a look at our example here. What I'm going to recommend that we start off with first is just by looking, we're going to use this diagram for these next 2 problems. So AC, segment AC, is my whole segment. And then AB is a part, and BC is also a part. So now I know what part, part, and whole are. So now I can work with part plus part equals whole, or in some cases we can say whole minus part equals remaining part. So, in our example, we're given that AB is equal to 12. Well, AB is a part, and BC is also the other part. So BC equals 7, and they want to find what the whole thing is. So if this part here is 12 and this part here is 7, when I combine those together, what's that going to equal? That's going to give me that segment AC is equal to 19. Let's take a look at the next example. The next example says that AC is 24. So AC is the whole thing. So the whole thing is 24. So the whole thing equals part plus part. BC is 15. That's a part. And they want to know what's AB. So I don't know what AB is. So to solve for this little algebra equation, we're just going to subtract 15 from both sides. That's a 5. And we get our answer. 24 minus 15 is equal to 9. So we get AB is 9. If you look at example number 3, no figure is given to us. So this is where you need to understand the vocabulary. We are told that CT is 16, JT is 2x plus 1, and CJ is 3x plus 5. J is between C and T. So what I would recommend that you do, go ahead and draw a little diagram and label it CT. And now we know that J is between that, so what we're going to do is we're going to put J somewhere. If you want to put it in the middle, you can. It doesn't have to be, but I'm just going to put it right there. And they want us to solve for x and find the measure of each segment. So there's two parts to this. We need to solve for x, and then we have to find the measure of each segment. So CT is the whole thing. So the whole thing is 16. Whole is equal to part plus part. Over here, so our parts are JT and CJ. So we're just going to add those two parts together. Plus 1 plus. So basically I just took JT plus CJ, and that's going to equal CT. So now this just kind of takes us back to our algebra days, memories, where all we're going to do now is combine like terms. So 2x plus 3x, that's 5x. And then if you want, you can subtract 1 and subtract 5 from both sides. So when I do that, I get 10 is equal to 5x. Divide both sides by 5, and you get x is equal to 2. But are we done? No, we are not done. So now we have to find the measure of each segment. So now we're going to substitute 2 into anywhere, basically, that we saw x. So we already know that CT is 16. So now JT, we're going to do 2 times 2 plus 1. 2 times 2 is 4. 4 plus 1 is 5. CJ, 3 times 2 plus 5. 3 times 2 is 6. 6 plus 5 is 11. And if you look back to our little equation here, JT plus CJ, JT plus CJ, 5 plus 11, hey, that equals 16. So that's kind of a nice way you can check yourself. Alright, once again, take a moment, pause the video, copy down these definitions, and I'll meet you back when you're finished. Okay, we're going to talk a little bit about some definitions here. Very vocab heavy this first unit, so make sure you know your vocabulary. Make sure you understand these words. Parallel lines, you've probably heard this before. Parallel lines are two or more lines that do not intersect and are coplanar. Remember, coplanar means they exist in the same plane. So for most of these examples, I'm going to draw a box. So let's say I have a box here. If I wanted to identify two parallel lines, I could say something like this and this. Notice they're in the same plane. So they're in this plane here. And they never intersect. Okay, parallel planes are two or more planes that do not intersect. So once again, I'm going to draw another box. So pretend that you have a box, and basically the planes are just like the top and the bottom of the box. So here's the top of the box, here's the bottom of the box, and those planes never intersect. So that's what parallel planes look like. Skew lines. Skew lines are lines that do not intersect, but are not coplanar. So it's kind of like they're parallel, but because they're in separate planes, the idea of them never intersecting, it's not physically possible. So imagine that you have a box, and let's say that you were looking at this particular line here, and then this line back here. These kind of are in totally different planes, and they never would intersect with each other. So that is called skew. Array. Array has one endpoint and continues forever in the other direction. So an example of what this looks like is it has an endpoint, A, and it goes in some direction, let's call it B. How you write that is like this. So it's not a line, it's array because it only has one arrow. So the very first letter is your end point or your start point. So when I say ray AB, you know that it's starting at A, and then the second letter tells you the direction. So it's starting at A and going in the direction of B. So that's what a ray is. Opposite rays are when you have two rays with a common endpoint that extend in opposite directions and form a straight line. So let's say that I had ray AB. So A is my endpoint going in the direction of B. I technically could draw this in the opposite direction and call this ray AC. So I have these two rays that are opposite rays. So it starts at A, goes in the direction of C. Starts at A, goes in the direction of B. And that's what opposite rays are. So what I'd like you to do now, these are sort of your try it questions. Take a moment, use the vocabulary. If you forgot what some of the words mean, go back and reread, look at our examples, and read the definitions. So fill these questions out, and these are what we will go over in class. Thank you for watching.